Namo Namaha. Andariki Namaskaramulu. Today is the 24th day of our lectures, webinars on Sanatana Dharma as part of second certificate course on Sanatana Dharma. We have finished 1 month of our coursework. Now we have started with the second month. This is the second day of the second month. The topic is Vedic mathematics by Dr. Goutham Mukherjee ji. So, as usual, we start with Vande Mataram by Chala Chittibabu Garu. Then we will have Prarthana by Ananthan ji. Then we will start with the webinar. Okay, let us start.
Vande Mataram, Vande Mataram, Sujalam, Sufalam, Malaya Sitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajyotsna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram Vande Mataram Vande Mataram.
Vande Mataram.
Vande.
Dhanyavadaha. Chala Chittibabu Garu. Now let us have Ananthan ji.
1 minute meditation. Let us close our eyes gently. Relax our body. Bring back our mind to the class. Give auto suggestion. Next 2 hours, I will not entertain any other thought other than the class. Total concentration on breathe. Without any interference. We shall pray God to make our mind available in the class for next 2 hours. Om. 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 Gananantva Ganapatigum Havamahe Kavim Kavinamupamashravastamam Jashtarajam Brahmanam Brahmanaspata Anashunvannoti Visidhasadanam Mahaganapataye Namaha Prano Devi Saraswati Vaje Bilvajinivati Dhinamavityavatu Vagdevyai Namaha Gurureva Gatir Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Na Guroh Paramam Shishurasmi Guroh मतिरस्ति गुरौ मम पाहि गुरो। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिं कृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे। श्रुतिस्मृतिपुराणानामालयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करम्। शङ्करं शङ्कराचार्यं केशवं बादरायणम् सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। हरिः ॐ श्रीगुरुभ्यो नमः। हरिः ॐ।
Hari Om, Dhanyavadah. Let us request Goutham ji to start his webinar.
Namaskar, Sabhabhai, Namaskar. Yeah, you are getting it properly with the slide view. And yesterday, just I had a small listing about the trick and so on. Today I will start with multiplication. Now, multiplication of certain types which are near a base. As you know, base, I will tell you, near a base, sometimes below, sometimes above, or one is above, one is below. So that kind of things can be handled using this kind of formula. We consider first that multiplication of the pattern of this type, where it is near to 100, near to 1000, near to 10,000, and so on. So a base is defined nearest power of 10, which must be the same for all multiplications. It is not that one multiplier has some other nearest 10 and some other not. It is not that. So let's take example. So this is 100 is the base. So here 97 is 3 short. So we write, because it 100, it is 2 zeros, and we have to make the similar amount of digits. So it is 10 to the power 2. So 2 digits has to be right. We cannot write -3, but to write -0. Similarly, this 93 becomes -07. The 7 short of the base. 93 is 7 short. Now the answer will be either you subtract this 97, either subtract 7 from 97, or 93 subtract 3 from 93. Either you subtract 7 from 97 or 3 from 93, they're all the same, it is 90, and then multiply the 3 and 7. Both are having minus, so it is becomes plus. So it, answer has become 9021. As simple as that. So I go to higher base, higher bases. base 1000. Earlier we had 100, now it is 1000. So 997. Similarly, I'm keeping the same numbers so that you understand what is the changes that is happening. 997 into 993. So here you write, earlier we wrote 03, now it is 003 to match the number of zeros in the 1000. 007. Similarly, exactly the same thing. Either you subtract this 003 from 993 or subtract 007 from 997, you get 990, and then you multiply with 3 by 7, and immediately keeping the same number of digits becomes 021. So this is the answer, 990021 answer. Similarly, 997, 993, you will find that if we keep the number of digits same, this idea, that means it is only 7 less or 3 less from this base. Only the number of nines will increase in the first part and number of zeros will increase in the second part. We took another different example with the same base at 10,000, 9876 into 9987. So it becomes 0124. How it is done? Nikhilam. So 10,000 minus 9876 you are doing basically. So it is formula is Nikhilam. So 9 becomes 0. Nikhilam from this Nikhilam Navatas. So 9 becomes 0. 8 becomes 1. 9 minus 8 is 1. 9 minus 7 is 2. So it becomes 1, 2. And last one is from 10. So it becomes 10 minus 6 is 4. So this way, this becomes the deficient from 10,000. Similarly, 9987, it is 0013. When we multiply, we get 1612. And 9876 minus 0013, 9863, same thing. And 9987 minus this 124 becomes 9863. So that way, a complicated looking multiplication like 9876 into 9987, it might take quite a long length of time. It becomes 4 lines, multiply with 7, 8, 9, all the high digits, and you have to do a lot of tables. This thing, apply a lot of tables, and then you write then and add that. All these things can be all saved. It is simply can be done by this one. What is the algebraic background with inside that? It is n minus a, but n is the base. It is a power of 10. N minus a into n minus b. It is actually n square minus an minus bn plus ab. So we write that same thing as taking n as a common. So you can n minus a minus b plus ab. Where this is already given, say 997. It is already n minus 3. This is some 3 is a and 7 is b. So it is already given n minus 3, and this is already 993 is already n minus 7 here. So what we do? N minus 7 minus 3, either as I told, that is cross subtraction. So it becomes n minus a minus b. Either you subtract this from this or this from this. In any sequence, becomes n minus a minus b. And we are multiplying this 3 into 7 into 21 becomes ab. And we are shifting the so many digits of the same as base. Base is 9. So this is multiplication equivalent to multiplication by n. So we are basically, it is nothing like, no trick or nothing like this thing. It is a rigorous algebraic application of an algebra. But the procedure is different. That's what we learned from our childhood. Instead of all the different procedures could have been come in the mainstream, somehow, unfortunately, this for a few centuries those didn't come. Only one kind of multiplication, one kind of subdivision we started learning. So depending on the case, the situation can be completely different. You can use a different algebra, and that leads to gets translated into a different procedure. That is what is required. You like we learned from childhood a particular procedure of multiplication or procedure of division. we can change the algebra in the background, and we can change the procedure, learn a new procedure. That is what is I want to emphasize, and that is basic mathematics, learning a new procedure. So I come to where it is multiplication.
Students want this n minus a minus b again. Yeah.
Yeah. See, this is actually 997 is 10,000. This 1000 minus 3. Okay. It is suppose it is A is 3 and B is 7 in this case. So this 997 is nothing but n minus a means 1000 minus 3, and n minus b is 1000 minus 7, 993. So we are making it 990, means that we are already it is n minus a, and here it is b. So in when we subtract this again from this one, it becomes n minus a minus b, this one. Or this was already n minus b, and this was a. So n minus b minus a, it becomes n minus a minus b. So this is the 990. Is it clear? And then this AB part is this one. 003 into 7, it is 3 into 7, A into B is 021. So we're adding that. But what we are shifting here, the shifting of these, because we are writing it towards left on so many digits, this it is multiplication by n is involved here automatically. When you are writing something in the left of that, automatically gets multiplied by the same number, same n, means same base, power of 10. Now the idea is clear. You can unmute them. They can directly talk to me with video on, so that I can I can talk to them directly.
Yeah, today they can all unmute themselves. We
Unmute,
haven't
and also
muted.
whenever you
Yeah,
talk,
anybody can talk directly.
directly,
But
and
they should mute themselves after they finish the talk. That's it. If
yeah,
there is
yeah,
no
and
background
when-
noises.
Gurugaru,
at the time
namaskar,
of talking,
Gurugaru. Guruji, namaskar.
Namaskar. Hey, please switch on your video also. So at the time of talking, please also switch on video.
Guruji,
Yeah, your Vasiti Shankaraya.
Ramesh Babu, sir.
Huh?
Ramesh
Ramesh.
Babu.
Please on your video. That's what he's saying.
Please switch on your video.
My phone is problem, sir. It is not coming.
Don't worry. Don't worry. Go ahead.
No,
Go ahead
no,
with
no
the
problem. Please continue. Please continue.
Sir, the base 9876, okay. That 1249987, that is also okay. That up to that I understood. Next answer 9863 and 1612. How it come? You may explain once, sir, please.
1612 is the multiplication of the 124 into 13.
Acha, direct multiplication. Okay.
Multiplication. This is the AB part. This is one AB part.
Okay.
And this is this subtracted when I subtract 13 from this one, or this 124 from this one, it results in 98663, which is n minus a minus b part. And the shifting towards left,
Minus a minus b. Okay.
it is equivalent to multiplication by n when you shift towards left.
Okay, sir.
So
Namaskar.
procedure is clear?
Yes, yes. Thank
Now,
you, sir.
It was near a base below. So now I come to above.
Thank you.
So in the same way, the multiplication of 107 into 103, or 1017 into 1012, 10,015 into something, and so on, can be 100. A base is defined, I repeat this, a base is defined as nearest power of 10 and must be same for all the multiplicants. Let us take example, this base 100 is 103. So here I write it is plus 03, because it is more than 100. How much more? 03 more, not 3, because it is have to keep the same number of digits. In fact, simpler than that, I could have done that. Say 13 into 17 I could have done, but anyway, they started from there because those are too obvious. So then not 107 is plus 07. So So again, it becomes addition. So 103 plus 07 becomes 110, or 107 plus 03 becomes also 110. And this similarly, this is multiplication. Both are plus, so it is again 21 plus. So the total result is 11021. So I go to higher basis. So similarly, we keep the same 7 and 3 for example. So 1007 into 1003 similarly becomes 007 003, and it becomes multiplication of them becomes 021. 1007 plus this becomes 1010, and the total becomes this one. Similarly, so as we have seen that we see that whenever we increase the number of zeros, keeping the same differences, I mean same deviation from the base is same, we only keeps on adding 0 in the first part as well as 0 in the second part. So you compare these things, it become keep on number of you can somebody can give you any number of zeros, but you will be, if the base their length is same, you can easily guess that how much should be number of zeros in both cases. Here we can take another numbers 10123 into 10,005. So becomes, we multiply these things 615 with keeping our 0, because same number of with 4 zeros are there in 10,000. It should be also 4 length. And similarly 10123 plus 5, or this one plus this one is 10128. So similarly the algebraic expression becomes same except the previous one, excepting that these are plus. And n plus a plus n plus n into n plus b becomes n into n plus a plus b. We already get n plus a and n plus b. When we add, cross add, it becomes n plus a plus b, and this second part is n ab, and we shifting left with so many digits, it becomes, it's involved in the multiplication of n means actually the shifting the digit towards left. So this is the same thing idea.
What is the sutra that is being followed here? The Sanskrit shloka that tells. That.
Here here sutra is earlier it was negative, so it was Nikilam Navatascharam Sutta was there. But here it is a simple multiplication with the procedure. It is not particular any sutra is there. It must be there some sutra, and it is not mentioned there, so I cannot tell you.
It's okay, Guruji. Thank you.
Sauchaya or something like that. But that is there, but it is not so challenging. Also, you didn't mention that earlier. It was a subtraction, so Nikilam Navatascharam Sutta was there. Anyway, it is there is some. The procedure is this one in the background. This is the in general it is called Apuri. It is in general it is falls under the Nikilam method. It is called multiplication under Nikilam. Although it is actually, since it is positive, there is no Nikilam is involved here. That is true. But it, sure. Will come again if it is mixed. I'll tell you how it comes.
Thanks, Guruji. Thank you.
Multiplication of the pattern is 97 into 103. One is less than base, another is more than base. 997 into 1012, 995, 995 into 10,030. And this kind of things can we handle? Only thing is that must be the same for all multiplication, power of 10. It is a near plus or minus. So take the example 93 into 107. It is minus 07. If here is the sign is very important. The sign will create a lot of considerations. 07, and this is plus 07. So this becomes, since it is 7 less and 7 more. Now, when you multiply, we have to be very careful now. So this first part is okay. 90, either you do 93 plus 7 or 107 minus 7. Both result in 100. But here, 07, one is minus 07 and it's plus 07 becomes 49 Vinculam. Basically, 49 is negative here, whole 49. So we have to make it, here is Nikilam Sutra comes, we make it 100, we write actually 10049 in Vinculam. What to do? From Vinculam to when you are doing bringing to positive numbers, you have to reduce it, because something was negative, we are reducing it to, we are making it positive. We are adding something, when it is from negative, we are doing it positive. So you have to compensate by reducing the previous number by 1. So it becomes, basically in the background, it is happening. This 1 minus 49 is 9951. So this is immediately one reduces, becomes 99, and this becomes 51. The Vinculam, the Nikilam Navatas Sarmadas 4 becomes 5 and 9 becomes 1. So it is 9951 is the answer. Is it clear? So this is this one. This is the expression I can write. There is no harm in writing this way. Although a higher number in Vinculam is not written. So earlier, for our purpose, we always wrote a higher positive number to negative, lower Vinculam number. But here it is already given as a result of the calculation it came. We converted it to normal number by making it Nikilam Navatas 5 and 1, and but reduce it the 1, because it's something negative and making positive. So we are compensating by subtracting 1. So 9951. It's clear? So you come to, let us come to more examples. Yeah. So exactly the same thing I do for other things also. 1013 and 993. So it becomes 013 and minus 007. So when I subtract 7 from 1013 or add 13 to 993, it becomes 1006, and plus 13 and minus 7, it becomes negative 91, and with keeping same number of 0, it is 0 Vinculam 91. Okay. 10,003 and 9993. It is plus 0003. It is minus 0007. It becomes 0021 Vinculam, and 9996. Either you subtract 7 from 10,003 or add 3 to this 9993, because 9996 and 0021 Vinculam. When you release that Vinculam, it becomes, this becomes reduced to 1005 and then 909. 909 why? 0 comes to 9, 9 comes to 0, 0 comes to 9, 9 comes to 0, and 1 comes to 9. And it is subtracted from 9, and this last one is subtracted from 10. So 909. And similarly, 21 becomes 79 Nikilam Navatas Sarmadasata. So this way, it Vinculam is clear. So this is about the mixed base. That is seen that increasing more number of zeros than 9 in multiplication results in addition of same number of zeros or 9 in the first part. At the case may be when it, if it is more or less, when the negative part is more or positive part is more, depending upon that, first part will be either with zeros or with nines, and number of zeros and second. Always there will be number of 0 in the second, but after clearing the Vinculam, it will be converted into 9. Algebraic expression for the n's using n and the base, the n plus a into n minus b, n plus a minus b minus a. Basically, algebraically speaking, these three, both the three formula are the same, because algebraically a number can be attached with positive or negative both. So the formula is same basically, but explicitly if we write taking A and B positive, so 13 is here, take the A as 13 and B as 7. So it is n plus A and n minus B. So n plus A minus B or n minus B plus A, the same thing, n plus A minus B, and minus AB is this one, minus, it is actually minus 91, so it is minus AB, and we shift towards left is multiplication by n base. Is it clear? Any doubt in this slide?
You can go ahead. I think.
Okay. Now, there is a concept of sub-base. So all the time we do not get near to a base, either starting with 99 or 1000 plus something. So here we get that two numbers near to 500. So this here we apply some concept called sub-base. Either you do base 1000, but in both cases the sub-base is 500, and but we can make either base 1000 or base 100. In both cases, the consideration will be different, slightly different. 483 becomes, we write minus 017. It is 17 less from 500. But keeping the number of digits in the base, we write 017. Whereas, if we take base as 100, we have to write only 17. That is the only difference. Here we write 017, here we write only 17. And 497, it is how much less from 500? The sub base 500, 003. And here it is keeping the same length as the base is 03. Is it clear, the difference? Here 500 is, this base is 500, 2 times 500. So it becomes, sorry, it is the base is half of 1000. So we divide by 2. Okay. So according to the base we apply. Here, in case of 100, it is 5 times, sub base is 5 times. So we multiply by 5. Here, similar to, we applied similar, actually 483 minus 3 is 480, 17 into 3, 0, keeping the same number, 051. Here also 483 minus 03 is 480, or 497 minus 17 is 480. And 17 into 3 is 51, but no 0 because it is the same number of digits. Okay? Only difference is that here we divide by 2 to get 240 and 051. Here we multiply by 5 to get 240051 and results in the same thing. Please try to understand if it is okay. And any question? Okay. Should I proceed?
Yeah, proceed.
Consider 235 into 247 with base 1000. Sub base actually it is a easy division. 1000 by 4 is 250. So 235 is 15 less than 250, and 247 is only 3 less than 250. So same way multiply, these things becomes 45. 235 minus 3 is 235 minus 3 is 232, or same thing, 247 minus 15 is 232. When this was 1000 divided by 4, so you divide by 4. So because we took something more, so we have to divide by 4. So it becomes 58 and 0456. 58045 is the answer. Here there is a slightly challenging, it comes actually. Earlier we didn't consider these things when if this overshoots. here we see that 18 into 45. Base is 1000, sub base is 1000 divided by 2 is 50. 18 is actually,
It's 100, it's not 1000.
100, sir.
oh, sorry, 100. Base is 100 and sub base is 100 divided by 2 is 50. Now, 18 is minus 32. 32 less than 50 and 45 is 5 less than this thing. So it becomes 18 minus 5 becomes 13, or 45 minus 32 is become also 13. Now 32 into 5, it becomes 160. That 1 we write as a less here. It is actually carry. It must be added to the previous one, but not now. After doing all these things, when you divide 13, it becomes 6.5. Okay. This half is actually half of what? Half of it 100. This is actually, if we draw a line, this is the unit tens digit and this 100 digits, 6.5. This 100 contributes to 50 when you goes to the other part, goes to the its below part. So this was originally 160, and this when you added this 50 here, it becomes 210. That 2 is a carry, and this 2 gets added to 6 becomes 8, and this becomes 10. So you have to understand, it will become slightly complicated, but this kind of cases will come. Earlier also, we didn't take much bigger base. I thought that is introduction one. I could have taken. In that case, only that suppose, I'll tell you, I'll go back.
Sir, I have a question.
Just let me what I'm telling. Suppose these are numbers are more, and something more comes here. Suppose it is more than 4 digits. And that will be added to the previous one. That is the only thing. And you add as a carry. Please, I'll come back to that one. Please tell me.
So here in the first example, you said 232 is divided by 4, which is fine. So I think you answered in the second question. So if we get a number not which is divisible by 4, then we'll get some fraction like in the second example, and then it will probably be a little bit more complicated.
Yeah.
Okay.
Complicated means only that you have to consider that what is the actual value of that. Here the half is means half of 6.5 in the 6.5 in the 100th digit. 100 place value. Place value is 100 here. This is the unit place. 6 is in the 10th place, and 6.5 sitting in the 100th place. In 100th place, this half becomes actually value is 50. It is a half of 100. Right. So that 50 can be added here. That's what 50 got added to this 160. It was already 160. One was carrying. So 160 and becomes 210. So we write again like this one, because we cannot write 200 becomes it will be 4 digit then 6210, not 6210. It is 6, and with the 10 it is carrying is 2 for the to be added to the 100th digit and becomes 8, and then becomes 810.
Okay.
So this is that
one. Okay, sir. Thank you so much.
Sir,
So,
in first example, you divided by 4. And second example, you divided 13 by 2. Why?
No. Here is the base, actually, sub base we consider as 50, because around 50 we made a calculation was made around 50. Here the calculation was made around 250. See, in 235 we wrote 15 because we calculated around 250. Here we calculated around 50. 18 we expressed as minus 32. 45 we took minus 0.5. Okay. After 18 we wrote minus 32. Is 18 is 32 less than 50. That's what. Okay.
Okay.
depending upon your subbase. Depending upon subbase and relation of your base with subbase, we divide or multiply. Okay. So a half in 100 position becomes 5 in 10 position. In 10th position becomes total is 50. Achha, this is explained. Achha, now algebra involved. What is the algebra in case of subbase? So algebra is subbase is like suppose we take 250. It is 1/4 of 1,000. So consider that m as 1/4, something like that. Any fraction we make. Fraction maybe more than that also. It's two times a base, 5 times. Earlier we have seen that subbase is 5 times the base. So if it is we represent by m is any factor, maybe for less than 1 or more than 1. So it is m into n minus a times m into a minus b. So this is number which is mn minus a, and this is mn minus b. So when you bring that, it becomes mn. Said that mn, how it is mn is created? N is created by and this one becomes mn minus a minus b. When you subtract this again, this becomes this particular number becomes mn minus a minus b, and this is ab. But here we are not fully shifting only, but we are making also the fraction is taking it action. We are multiplied by this 4, means here it is 1/4. We are dividing by 4 to get 558 and 0.
Excuse me, sir. Sir, can you make the pointer a little bit bigger, sir, so that we can see where exactly you are pointing out? Pointer, sir. It is not visible. That is the reason we are unable to follow, sir.
Pointer is not visible.
Maybe on a mobile it is not visible. On a laptop it is visible.
Now I will make it pen.
It is visible.
Laptop it is visible.
Are you getting in the below? I wrote a underline.
We are seeing it. Achha. People from mobile,
Yes,
they
yes.
should answer. Yeah.
If color is there, you make the pointer colored one, sir.
This one. I was referring to this particular thing, this formula. Mn minus a into mn. Let me erase and do it. This particular formula I was taking, and this is mn minus a is the 232 is either you write mn minus a minus b, and this is this plus ab part, and again this instead of n you are writing mn. So basically this m is a factor. This factor in case of this one is a 1/4. So we are dividing by 4 to get 58. Is it this point is clear? Anybody has any doubt?
Guruji, I think it would help if we can tell as to what is m, what is n, what is a, what is b at the beginning.
Oh, yeah.
So that way it will be very easy to.
Suppose, yes. This 235 is our given number, and it is a near to this 250. So here this is m into n. This is m into n, and this is a. 15 is a, for example. This is a, and 3 is b. So this it is from mn. It is a less. So mn minus mn. Mn is this one. Mn is this one. This is mn. Some fraction or multiplication of the base. Base is n. Base is this is n, and this is mn. This particular number 235 is mn minus a, because a is 15, and this 247 is mn minus b, because it is b is 3, so it is 253 minus 3, and this 232 is what? Mn minus a minus b, mn minus a minus b. 232. Okay, we subtracted these from these or subtracted this from this becomes 232. Mn minus A minus B. And this part is A into B, 45. But instead of just shifting here, this is 232,045 is not the answer because we made it, we didn't multiply or divide anything from AB. AB remains intact. But what we did, we shifted to left. That means it is multiplication by Mn, but multiplication by N, but again we multiply by M so that this becomes 1/4 of that becomes 58. And then this plus AB is intact as a plus AB. So this is 58 with 580. Is it clear now?
Yeah, I think
Anything unclear? Anything unclear?
no problem. Go ahead.
This is the role of the base to sub base relation, that factor M. Either it can be more, like we earlier have seen that 100 and 500 or 1000, and in case of mostly it is fraction is also used and 100. That can be also used.
Guruji, how did we get this 232?
Huh? Oh, 235 minus 3, 232. Or 247 minus 15. Same thing. Mn minus A minus B. Okay. It is the same thing as we did in base, but only difference is that always M is attached to the N. N means power of 10. A capital N is power of 10. This capital N is power of 10. And it is Mn is we multiplied by something. In case of here, it is 4, 1/4. And near about that sub base, we do calculation like this one, Mn minus A minus B. And finally, we multiply that by this particular fraction, and then it gets that final result. Clear? Okay, we'll have more example if you like. Or we want some more explanation before we proceed.
Yes, sir. Can you repeat it? 232 divided by 4.
58.
Just to 58 and right में 045 and 045. How it came?
Now, we are not dividing everything by 4. As I wrote here, we divide only this part. See, 232 is actually N into Mn minus A minus B. N into capital N into Mn minus A minus B is 232. We only divide 4 for that one. This part. This first part is there, second part is there. The 45 remains intact. I mean, AB part. This AB part. This is the AB part. This is the AB. This is the AB part plus AB, no? And this is that Mn minus A minus B, the 232. We are dividing 4. I mean, you have shifted actually by N. Already digits are shifted. We are dividing, we are multiplied this by M, the whole thing. And this is remaining intact. We are not dividing everything by 4. We are dividing only the first part, not the
How
second.
we got 045?
Huh? 045.
Yes,
This is the 15 into 3, keeping the same number of digits. 15 into 3 is 45, no? But it is a base is 1000, so we have to keep 3 digits. So 3 digits are kept here.
Good.
Here see base Here in the left, right part, you see the 32 into 5. We can keep only 2 digits. So 1 I'm carrying. 1 is kept as a small. This is also another procedure. This is very interesting actually. So this has to be added with this one. Actually, it should be. I could have added also. It becomes 7.5, but 7.5 then becomes the same thing actually. If it is, suppose it had been only 7, this could have made it 8, like this one. So here we wrote again this one. Rather, there will be more questions I expected from the right example.
Guruji, that's what, how it became 8 and 10 on the right side, because that was a confusion. 8.
Oh, actually, as I explained here, 50 plus 160 is 210. So these contributed 50 to this one. The half thing actually contributed to 50 in this case. 160, it was already 160. When you add 50 to it, becomes 210. We write 210. There is no place to write 2. 2 is carry. So it is 10 you have to write only. But 2 is carry, means it will be added to 6. So it becomes 8. The answer becomes 810. Clear?
Hope it's clear. Yeah. Go ahead, sir.
Okay. Now, if we like, we can sometimes we can have you can design your own problem, which is about same length, and we can come back to this one. Please. Now we come to another topic. This Tirjog method. Tirjog method is actually for it is general. We don't have to consider about near about base or their length or something like that. So it is like 43 into 25 we want to do. What we do, we do it this way. All the unit digits, all the 10 digits, all the 100 digits, we keep on writing in their proper sequence. Either even you can write from left to right or right to left, doesn't matter really. Because later on it will be added. So here I give the example of 43 into 25. What you do, the rightmost digit will be 3 into 5. This is this BD like this. So it becomes 5 and carry 1. Middle one will be 4 into 5 plus 3 into 2, which is 26. 4 into 5 is 20 plus 3 into 2 is 6 is 26. So write 6 and 2 as a carry, and 4 into 2 is 8. So it becomes in the top it is 861, but it is carrying is 2 and 1. So when you add, it is 5, and 6 plus 1 is 7, and 8 plus 2 is 10. It is doing a different sort of algebra than what we conventional mathematics we do, conventional or 2-digit, 3-digit multiplication we do. It is some other way. And here we require to have, sometimes you have to memorize a little. Memorizing is required, and mental calculation, and final after mental calculation you write this thing finally. But it has been seen very peculiar actually. I could have told it later also. Anyway, when I it has been seen that total precision.
Sorry to interrupt, sir. Could you please go to previous slide?
Yeah.
So I get it, like 43 into 25. So 3 into 5 is 15. And then 4 into 2 is 8. And then you said in between you do a cross multiplication, which is also fine. But then something which I'm probably missing is, okay, 8 is written as is. So where is 26 and 15 written? Like what is happening?
Carry. we are writing carry shifted towards. So this is 15, and where is my cursor? This is 15. Isn't it?
Okay, okay, I get it. Okay,
This is 15 and this is 26.
okay,
Carry we will be writing below and left, so that it can be added later. 6 plus 7 added to 7. 6 plus 1 added to 7.
okay, okay. So the notation is totally different, like the way we write.
Notation is different.
Okay, okay, sir. Thank you.
Because algebra is different. Earlier we used some other algebra. Now algebra is this. It is the same thing, same truth, same calculation, same mathematics, but the procedure, intermediate steps are different, you can say.
Okay, sir. Thank you so much.
And similarly, now we get higher number of digits. 100A plus 10B plus C plus 100P plus 10Q plus R. So it becomes like that, this one. How you do? Leftmost digits will be only 3 into 3, 9. Or if we are normally comfortable from considering from right to left. Left to right. Oh, I'm sorry, right to left, right to left. 4 into 8, that will be put down at 8. Next one will be cross multiplication up to 1 into 2 plus 4 into 5. So 1 into 2 plus 4 into 5 is 22. 2 we write here, and another 2 we write as a carry, left and below. Now middle one will be 3 into 2 plus 4 into 3 plus 1 into 5. And therefore it is called Urdhva Tirjagabham. Actually, I didn't, sorry, I could have done in the very beginning this Tirjag method. Tirjag method actually is, there is one formula called Urdhva Tirjagabham. It is upper as well as slant. So here, see, it is 3 into 2, this 3 into 2, plus 4 into 3, plus 1 into 5. This also upper, directly upper, 1 into 5. So this added to 23. 3 we write here, and 2 we do below and left. Next, this will be 3 into 5 plus 1 into 3 becomes 18. It becomes 8 we write here and 1 we write here. And this of course becomes 3 into 3 is 9. So when we add, this becomes this one. Clear?
Please explain once again, sir.
This is 3 digits. So here all the consideration will be there. See, if you see the algebraic term, in the background there is algebra.
These are 9.
But we are practicing as a procedure. If you see the algebra, rightmost term is CR. It is the unit digits, only multiplying directly. Next one is cross multiplication between the test digit and unit digit. That total multiplication becomes 10. But next one, this previous to that, 100 digits will be how much? 100 digits will be 100. In the unit digits, it will be 100. Multiplied directly by 1:1. But this one, no, I'm sorry. This this 100 digits will be either 100 digits from the first one, and 100 digits, the unit digit will be second one, and this one, and or 10 digits from first one, and 10 digits from the second one, both from 10 digits. 10 into 10 is 100. So this one, see, this is A into R. This is 100 digits A, and this is the R is this is the 100 digits of first one, and this is the unit digits of second one. This gets multiplied to AR, and this one 10 digits of first one and 10 digits of second one becomes BQ, and this gets multiplied. This is the unit digits of first one and 100 digits of second one, and added to this one gets CP, and all becomes actually total 100 digits. So that is what is happening here. 3 into 2 plus 4 into 3 plus 1 into 5. So therefore this cross kind of thing is given. And similarly, this one about 1,000 digits, and this is 10,000 digits. Only 100 into 100 is 10,000. So this 300 into 300 becomes 90,000. So this is the 10. This is the background algebra is this one. You can see that this is the explanation of all the kind of cross multiplications. Okay, should I proceed?
Yeah, you can proceed. And basically, when students, I think, will be given this PowerPoint so that they can.
No, PowerPoint
practice.
I have already shared, no?
Right. Okay. Fine. Fine.
You can go through that.
Right.
I discuss more example, becomes larger and larger. So it looks very complicated here, but therefore in the next slide I made it in a sparse method. I separated them. The background algebra is this. Oh, background algebra I didn't write. Similarly, it can be wrote. So I wrote in a sparse manner so that you can see that how the digits are coming. Obviously, when a 5-digit number is multiplied with another 5-digit number, either you can expect, depending upon the first digit of the 5-digit numbers, either you can get a 10-digit number or a 9-digit number. At least you will get a 9-digit number.
Sir, in previous slide, unable to understand to multiplication. First row is clear, second row is not clear.
Which one? This one?
Yeah. First 3 multiply 3, okay. And then 3 multiply 5.
Plus 1 multiplied by 5.
Yeah.
1 multiplied by 3. This 3 multiplied by 3, 5, and 1 multiplied by 3. This one. This cross. Okay.
Yeah. And
third one is this multiplied by this one, this multiplied by this one, and this state, this one multiplied by this one, as I wrote here.
And how is there again 122?
Where? 23.
122.
122, how has that become? Because there's 8 and 1, 3 and 2.
Acha.
Yeah.
These are the carries. 8 has no carry, but this 22, this 22 is the carry one. This is 23. This is 23. This is 18. This is 18. Okay. Carry we write below and left. Okay.
Again repeat. Carry.
We write below. Carry we write below and left because it has more power. It has more value of higher place value. Higher place value goes to left. So when 10 is multiplied with 10, it becomes 100. So that is so it becomes a higher place value. So that is the idea. So I will give more example. I will see. Here it is actually. Here actually looks very complicated. In any case, this one I write. Okay. So now we'll do it. And with a little application of vinculum, how it became easier, that also we have to see. 2, 3, 4, 3, 1, and 3, 5, 6, 4, 2. First one is state. 1 into 1 is 2. Okay. Second one is 3 into 2 plus 4. So becomes 10. This 10 we write, 0 we write here, and 1 we write below left. Clear? Up to this is clear?
Yeah, go ahead.
Yeah. Next one, 4 into 2 plus 1 into 6 plus 3 into 4. So, 26. Okay. So 26 write like this. 26. Okay. Next one. Next one is 3 into 2 plus 1 into 5 plus 4 into 4 plus 3 into 6. Looks complicated, no? It is actually 45. I wrote actually in this format, I wrote here. See, leftmost is this one, the left part one is this one, 10 digit is this. Next is 2 into 6 plus into 4 into 39. This becomes 55. This becomes, I think, 39, then 55. You are considering from leftmost digit. So here we this you note down somewhere this 26, 45, 58, 55, okay, 39, 19, and 6. You may note down somewhere. So how it is coming? How they are coming? These are coming by different multiplication. Middle one is more looks more complicated. 5 into this 2 into 2 plus 3 into 4 plus 4 into 6 plus 3 into 5 plus 1 into 3. Okay. So this one I wrote in a clearly placed manner. Those somebody noted down those things. This 2 into 3 is 6. Next one was 19. Okay. Then was 39 from right to left, from left to right. 55, 58, 45, 26, and 10, and finally 2. Those are the two various numbers, various calculations, intermediate calculations, and it became total added to this becomes like this. But suppose we make it using vinculum. That's what I wanted to show. It's very big, but by sometimes it is more than 5. We can consider it by doing vinculum. So 2, 3, 4, 3, 1 is okay, but it becomes 356 becomes 4 and 44 as vinculum, and then 42. How the calculation, see, carry becomes 2 less now, and sometimes in negative also. So 3 into 2 plus 1 into 4 is 1 into 2 is 2. 3 into 2 plus 1 into 4 is 10. It becomes 10. But here 4 into 2 minus, so 4 into 2 8 minus 4. This is minus 4 plus 12 plus 12 becomes 16. Becomes 16. After that, 3 into 2 minus 4 into 1, because minus 4 is there. And 4 into 4, again, minus 3 into 4, because this becomes 4 and this becomes 8 negative. Okay. No, not 8. This is not done. This one is 6, becomes 6. This one I was talking. I'm referring to this one. So I'll tell you. 3 into 2. 3 into 2, this one. Minus 4 into 1. Again, this one. Plus 4 into 4. And 4 into 4. Plus 3 into minus 4. Minus 4 into 3. This becomes 6. This is minus 4. 16. Minus 12. Total is 6. This is that 6. And next one is 2 into 2 plus 1 into 4 minus 3 into 4 minus 4 into 4. It becomes to negative 8. 8 vinculum. Similarly, that way you could do 8 vinculum, 4 vinculum, 4 and 8. So this ultimately added, when added with this one, 8 4 vinculum, 8 vinculum, 8 vinculum, 7 7 0 8. When you clear the vinculums, this 4 and 4 8 8 becomes 5 1 2 and 3. This one. Okay. Nikhilam Navatas Charmodasata. We are converting from negative to positive, so this is the it is compensated by making it 3. This one. And this is Nikhilam Navatas, 4 becomes 5, 8 becomes 1, and Charamodasata, 8 becomes 2. So finally arrive at the same result. This is the I wanted to show that how using vinculum this your calculation, mental calculation gets reduced. We sometimes subtract also, so you don't have to track those all the bigger number, and you become
Guruji,
58,
namaskar.
55. Okay, 58, 55. Instead of that, we are getting only 16.
Guruji,
16.
Guruji,
Please.
Guruji, in vinculum,
Uh,
2 3 4 3 1 okay. And the bottom line 4 times 4 4 4 4 2 came. This is the basic.
4 negative. 4 this 4 is positive. The other 2 4s are positive. 2 4s are negative.
Yes. How it came, Guruji? That is only first basic I am missing kindly.
Oh, achha, achha. See, 3. This 56. I converted into you actually could have written also, could have written like this also. I could have made it in a 56. Now, it's not possible. 64, how to make it 62 good?
100 minus 56 or 9 minus 5,
No,
4,
not,
10 minus 6, 4.
obviously. It is 9 minus only. 9 minus. I was thinking that whether we could have added, avoided 2 vinculums, we could have added only 1 vinculum. No, it is not possible here. See, 356. So if 6 is more, see, 6 is only more than 5. 5 is 5. 6 is more than 5. So, but if I write it like this one, it will not serve our purpose. It becomes 6 and 4. Like this one. But this also will not serve our purpose, because this became more than, this was 5. But in order to write this next one as vinculum, this becomes 6, which is not desirable. So we again do it 4 and 4 and 4. But if we consider, yes, it is Nikhilam Navatas Charamam Dasata, because This is Nikhilam Navatas Charamadasa. This is we subtract from 9. This we subtract from 10. And in that process, the previous one, because we are something from positive, we are making negative. So you have to compensate by adding 1 to 3. So it becomes 4 and this 4. In the bottom, I earlier told, no, this is more than 5. If it is more, if it is 5, it is optional, something like that we told earlier, but actually not. Not always, because if it is inside embedded somewhere, normally with 5 also you have to change finally, because 5 becomes 6 here. So that you have to finally it is better to write in this 4 format. Otherwise you have to always carry 6 here. Clear?
Okay, Guruji, I got it.
So this I wanted to show that how using a vinculum makes it further easier. Now comparison between different multiplication methods. Now same multiplication we can do in various ways. Urdu Tirjagambham. Suppose you are given 889 and 898. And we only Urdu Tirjagambham we use, it will become very big. 8 into 9 becomes 72. 8 into 8 plus 9 into 9 becomes 145. The whole thing, 145. 8 into 8 plus 9 into 8 plus 8 into 9 becomes 208. 8 into 9 into 8 into 8 becomes 136. I wrote it this way, 136. And 8 into 8 becomes 64. We add to this one. Becomes very big. So instead of that, we convert it into vinculum. So it becomes 1 and 111 in vinculum. And 898 becomes, because this is 1000 minus 111. And this is 1000 minus 102. Because it is expressed in the same way. But procedure is done with Urdu Tirjagambham. So it becomes 1 into 2. Vinculum 1 into vinculum 2 becomes positive 2. Vinculum 1 into vinculum 2, it is 2, and this 1 becomes 0. This 2. 1 into 2, this is 2, plus 1, plus this one again becomes 3. Here is 1 into minus 2, minus 2, minus 1, minus 3, and then plus 1 is 0, of course. It is minus 2 vinculum. This way, if we keep on writing, 1 into 0, minus 1 into 1, and 1 into 1 becomes this one, 0. This one is 0. Minus 2, minus 1, and again this one, 2 becomes 0. And this 1 into 1, minus 1, 1 into minus 1 becomes minus 2. And 1 into 1 becomes 1. If we convert it, clear the vinculum, 3 to 2 remains as it is. This 1 and vinculum 202 becomes 798. This one. Nikhilam Navatas Charamadasutta. 1 becomes 0. You are clearing the vinculum, so it is reduced. And 2 becomes 7, 0 becomes 9, and 2 becomes 8. Charamadasutta. And 3 to 2 remains 3 to 2, 793. In the Nikhilam method, where we did that n minus a into n minus b, same
Sorry,
thing.
Guruji, could you please repeat how you converted the vinculum response to the final answer? Could you please repeat that?
202. I mean, negative 202 becomes 0, of course, is vinculum or not, doesn't matter for 0. So they have not put that this bar we can put or not bar, doesn't matter. 2 becomes 7. 9 minus 2 is 7. 9 minus 0 is 9. And 10 minus 2 is Charamang Dasata. 10 minus 2 is 8. And when you are converting from vinculum to one negative number to positive, so you have to compensate by reducing this 1. So 1 becomes 0. So do not write 0 here because left 0 is not written. And 3 to 2 of course is unaffected. 3 to 2 gets 3.
Okay, thank you, sir. Thank you so much.
Now Nikhila method 889 from the very beginning we write this is a similarity. But if you see the logic, but of course calculations are different. It is actually minus 11, 111. It is actually Nikhila base is 1000. Base 1000. So it is 111 less than 100, 1000. It is 102 less than 898. But when you multiply this 889 minus 102 is 787 or 898 minus 111 is 787. But here, what we so far we didn't do, did enough different sequence. 111 into 112. We write it, we do it separately. This is new because we may not calculate 111 into 102 by our conventional method or by calculator. Not required. 111 again, the base is 100 here. It is 11 more than that, and it's 2 more than that, becomes 22. And we go 111 plus 2 becomes, or 102 plus 11 becomes 113. But 113 this one. But there is only 3 digits here, 3 digits. So this 11322, how you write? 322 we write here. 11 becomes in carry. 11 becomes carry. That carry gets added to earlier this n minus a minus b part, which is 787. We add 11 to that, becomes 798. Is it clear? This part is clear? This part is clear? How it 11 comes here?
Yeah, I think you can go ahead. Yeah.
It's clear to everybody?
Yeah, you can go ahead.
I could have written this one. There also another convention that you write small, this one, carry. But
Yeah.
it is the same thing. There is space, so I wrote below and left. So it contributed. This actually becomes contributing to 1000, it becomes 10,000. So similarly, it will be contributing similarly in proper place and added to 798. Now compare this with our same things we compare with our conventional methods without a vinculum. Conventional method we never use vinculum because we never knew that a place within a place value, a face value can be negative also. We never use negative face value. So what we do, we write conventional method. 889 into 898, we multiply everything by 8, like what we do, 7112. Multiply everything by 9 and shift towards left, 8001. Multiply everything on the top by 8 and become 7112. Add these things. So you have to write lot of. You have to write lot of. When you have to do very high calculations, very high multiplications, and finally add to that one. Whereas if we convert into vinculum and we write our conventional method, we write everything, multiply everything by minus 2 becomes 2 bar and 2 to 2. And 0, of course, it is, I didn't write that line at all. Instead of that, the next line I shifted two places. Isn't it? I wrote shifted 2 places. So this negative one, it becomes this one positive, this one negative, and all are positive. And 1 multiplied by this one becomes. And when you add, we add to this one. like what we did earlier also. There also we got it. This one also, no? Here also we got the same number. Here we also got our conventional method, we got the same number. We clear the vinculum, we again got the same number. So there are total 4 ways, 5 ways, you can say. Urdhva Tirjagam have 2 types, without vinculum, with vinculum. There is another Nikhilam method. With conventional method, we write without vinculum and with vinculum. So total 5 methods. And the purpose of Vedic mathematics is that, given the problem, you choose the best one. Automatically your intuition will tell that given a particular case, which is the best one to choose so that our effort becomes minimum. So that is the main idea of Vedic mathematics. You learn more than one procedure, and you finally arrive to the best, easiest way. Now, algebraic method comparison. Given 2 3-digit numbers, the conventional method performs this way.
This is a new topic. No?
Conventional method, we multiply, this is just the top number, this is the bottom number. Okay. First you multiply everything by unit, everything on the top line by the unit digits.
Yeah,
Right?
Gautamji, what Kalal is saying is that it's 8 o'clock. So if you are starting something new, it can be done tomorrow.
Oh no, this is part of the next one.
Right.
Will be, this is the division. Division will start tomorrow. This is just a small corner.
Go ahead.
And this is, see, conventional method, we multiply everything by R, left, rightmost digit, and then everything by the next one, 10th digit, and shift one place because multiplied by 10, equivalent to that. And next we multiply by 3rd line, and finally these are added. And whereas in the Tirjak method, what we do? In Tirjak method, we did this way. The same algebra we express in a different way, and all the unit digits, all the 10 digits, all the 100 digits, these are clubbed together. And if there is a carry, we add that. But the place is the particular place of a particular digit has been already fixed, excepting the carry. If the carry has to be added. So Tirjak method has been proved to be more efficient through research. It has been actually it has been seen that compared to the conventional method, the Tirjak method, if it is embedded in the circuitry, in the architecture of the computer or mobile, it becomes faster. Because see, mobile always may not be calculation. Even if you are displaying something in a particular corner or any place of a mobile or this thing, in order to display also, not many in the background, not many multiplication takes place. So if all the multiplication are converted into Tirjak map, it will be saving power. Even if seen that it will be more efficient, it will be even kilowatt, megawatts of watts of power will be saved by using Vedic mathematics, and because it is easier and consuming less time, less processing time. Okay, I finish it here. Please open for questions.
Mahadaya, questions are continuously being asked. Actually, in earlier lectures, we used to have lecture and then question answers. Now it is only question answers and lecture.
Still,
Is that today's session, everything is understood or not properly?
Yeah.
Okay, somebody asked the question. Let us, Gupta ji.
Okay. Please switch on your video also.
Namaskar, Mahoday.
Namaskar.
But for
your video, please. Yes.
Namaskar, Mahoday.
Namaskar.
But for the concept of vinculum, other multiplication methods, they are there in the conventional method also, because we have learned when we are as a kid. But only vinculum concept is a really wonderful. That is what I understood from the Vedic mathematics. Am I correct?
Yeah, but Tirjak method is different. Tirjak method is of course different.
No, but Tirjak method, is there any formula for the Tirjak method? Any say shlokam?
Urdhva Tirjakabhyam. Urdhva Tirjakabhyam. So you wrote here.
Because we learned it not as a part of a Vedic mathematics, but as a fun with mathematics book. We have learned this method, Tirjak method, long back.
Tirjak method is called Urdhva Tirjakabhyam. Means upper and slant. Upper straight and slant. Urdhva Tirjakabhyam. We are doing the upper, but it's both slant as well as straight. So this is about this one. Any question regarding this change in algebra? Both the algebra, how the conventional method, the 3 lines we write. In case of 3 digits, we write 3 lines. Explanation of the 3 lines here. Whereas in case of Tirjakabhyam, we mix them. From the very beginning, they are mixed, and finally the carry is added. That is the only difference. Okay.
Okay, thank you. Thank you, Goutham ji. Today we have completed multiplication. Yesterday we did addition. And tomorrow we are going to do division.
Divisions.
Yeah. Thank you very much. Let us do prarthana.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्याय्येन मार्गेण महिं महिषाः ब्राह्मणेभ्यः शुभमस्तु सर्वे भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितः ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनाः सदनाः सन्तु जीवन्तु शरदां शतम् सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे पश्यन्तु मा कश्चित् दुःखभाग् भवेत् तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः हरिः ॐ श्रीगुरुभ्यो नमः हरिः ॐ
ధన్యవాదాలు. Let us do జనగణమన. చల్లా చిట్టిబాబు గారు.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद
जय. Okay.
Shall I end it?
Yeah. Let us end it.